Good afternoon. This is Jenny Helrong with the Statistics Division of ASQ. We have a great speaker today. Our talk this morning is on the Lean Six Sigma to transform education. And a couple quick reminders. If you can ask your questions through the chat, we will have a Q&A at the end of the presentation. I will be sending an email with your RUs for watching the webinar within a couple days of today. And the presentation slides will I'll either send a link or I'll send the slides after the presentation with that email. And I'll have the link to the YouTube where the webinar will be posted for your information. Our presenter today is Mutaz Zreen, and I apologize for the pronunciation. And he has a wealth of experience. He has an engineering degree in electrical engineering from Dalhousie University and a master's degree in project management from the University of Quebec. He's a licensed professional engineer and a project management professional, certification holder, a certified Scrum Master, and a product owner from the Scrum Alliance, and a certified ITIL and change management practitioner from the APM group. And he has a lot of experience and a lot to share with us today. So I welcome our speaker, and I'm going to turn it over to him now. Thank you.
Great. Thank you very much. Thank you very much, Jennifer, for this introduction, and welcome everybody. I am Mutaz, like Jennifer introduced me, and I'm based in Ottawa, Canada. And I look forward to spend the next hour with you talking about Lean Six Sigma and how to implement this in education sector, how to improve education services using Lean Six Sigma. And again, this is the topic of this webinar. And let me see here, I'm going to switch to this slide here. Okay, so our webinar today will have this content outline, which is first, what I'm going to do is introduce Lean Six Sigma methodology, which maybe some of you already are familiar with it, maybe some are not. And I will go through a couple of slides, like introducing the Six Sigma methodology, Lean Six Sigma. And next, after that, we'll talk about variations in the education sector, which variations in the sense that things that we experience when we are providing a service like administration, test appraisal, marking, student performance appraisal. So we want to understand, you know, what variations exist in that sector. You know? And then we'll talk about the principles of Lean when they're mapped to the education sector. So, and then we'll take an example applying DMAIC cycle for problem solving in the education. So as you see, every topic is really discussing the education sector. So what is Lean? It's a methodology, or if you like, framework or approach to solve problems, improve processes by solving problems that exist in the process. And eventually, Lean Six Sigma, the main goal of it is to really minimize waste and speed up the process, make it more efficient and effective. So Lean by itself is a methodology, and Six Sigma also by itself. They were separate before, and it turns out then when they merge together, they will give maximum benefits. So the lean methodology is there to minimize the waste and maximize the customer value delivered to the customer. So we end up not having so much waste in the process. And then Six Sigma is there to minimize the variations, which means really make the process consistent, having a consistent output. I just put it there in the bullet form, more consistent process output. And together, you're getting combined benefits from both. It's been there for decades. It's been used initially in manufacturing. It came out from manufacturing, but that doesn't mean that it cannot be applied in other industries. It is now applied mainly manufacturing all over the world really has to consider Lean Six Sigma for process improvement and for minimizing waste. But now we have other industries like services, logistics, call centers, education is one sector that can have a lot of benefits from applying it. So the idea here is that when we say education, we have customers. Who are the customers in education? It's the students. The students want to enjoy their learning, the learning journey. They want to feel that they're getting value added from our service. Let's say we are the university or the school, college, or high school. I mean, education is a general term. It can also include training in private sector, company training. So the student is the ultimate customer who is looking for value. What's in it for me? Is this school gonna be helping me to learn and enjoy my learning experience, or is it gonna be difficult to learn or go through a difficult time? And so that's where we have to think now lean process when it comes to really administering student enrollment, the process steps from beginning to end, from acceptance in a program all the way down to graduation. So what happens in between? So we need to really streamline the process and understand how to minimize the waste, make the process more efficient, effective, improving the quality of education. So lean is really responsible for simplifying processes, eliminating waste, reducing cost, increase speed. Speed meaning like in any way, whether it is like receiving applications to the program, screening candidates and sending out acceptance letters. That starts like it has to be done with speed. It cannot be, slow response or same thing as we are dealing with students. As we know, we were all students. We have certain stress level. We're anxious. And when I send an email to my professor, I want a response back within 24 hours, if maximum. Like you can't, the school cannot reply back to my inquiry email or question or through the learning management system. If I just send some notes or question, I want quick answer. So that's like what the speed is about. Okay, for example, now Six Sigma is there to reduce variation mainly, meaning like acceptance. Let's start with the application process. within 2 weeks, all the applicants will get answers, whether they're accepted or not. Like 2 weeks on average, plus or minus 2 days. We can have always like tolerance limits set. And so therefore the variation is there to be, if it is too much, we need to reduce it. Like we cannot have too much variation, and variation, to reduce variation, we need data. So how long it took us for every application. So that data is available in the system. And now we say, okay, if it is centered around an average time with an acceptable plus or minus days, then we say, okay, if not, then we have to reduce it by applying Six Sigma methodology. So together, fast, efficient process, effective process, and improved quality. So you get combined power from both. This is an analogy, an example that I like, sometimes I use. Let's say the process is about picking up apple farm or whatever. So lean works for the bulk, like 70% of the apples, around that. I mean, when I get 70 from, because there is a quote attributed to Dr. Edward Deming. He says 70% of the problems are in the process. See here, I'm showing you a process, and lean handles all the waste in the process. So that's like 70% of the problems are resolved. And Six Sigma will be an added on benefit, which is taking care of variation. And variation is represented by just symbolic bell curve. We know that bell 100% normal curve rarely, it doesn't exist, but we just use it to represent a process. And Six Sigma will minimize the variation. And just those apples on the floor that fell down by themselves, you just have to pick them. You don't need any of these two. So we have to have documented processes in our educational institution. The best is to have process maps like this flow chart. And these process maps are designed for minimum waste and reviewed regularly to see how we can improve them to minimize the waste, or try to be innovative in the sense that using technology, some steps you don't need to do anymore, some steps you can automate, and by using new technology, new software. So digitize your forms, like all the forms, application forms can be, as you know, today we have digital forms on the screen, you fill them and they get saved automatically in the system. So the student can go in, do like an application, and it gets saved and sent right away. So these are all tricks that we can use to really speed up the process and make it less prone to errors, and more efficient, less resources used as well. So an example, like how do we measure variation in the process? We have, like mathematically, we can see that we have two statistics that we use, the range and the standard deviation around the mean. So those two figures or numbers tell me about how much spread is there in my distribution. And that's very important. We all understand, like the other day, let's say my son comes to me, say, I got 90 in the math test. Say, wow, 90% is good, but what was the class average, or what was the standard deviation, from the average? So if the class average was 89, well, 90 is average, really, compared to the other students. So it's good. It's a good mark by itself, but it doesn't mean much when it comes to comparing to the other students, because the average was like, let's say, 89. So calculating the spread is very important to understand how the data is being distributed. And now let me show you. So I mean, sigma, this is called sigma for the standard deviation. It's calculated mathematically like this: square root of the sum of x sub I minus x bar. So I take every data point, minus it from the average, square it, divided by n minus 1. Let's say n is whatever, 30, 50 data points, 50 students, let's say. And then I can calculate the standard deviation. So usually schools, they want to maintain certain average, which is this one here in the middle, and the standard deviation. So they want to maintain a certain average score of the marks, right? So it's like you don't want the average mark to drop down too much, because that means there is a problem. And I will show you an example, a few slides coming up. So this is the mean and standard deviation. When you plot the process curve, whatever this represents, marks in math test or averages, it doesn't matter, whatever it represents. So we have a curve like this. It's called the normal bell curve. And if we go up to 6 standard deviations to the right above the mean, and 6 standard deviations below the mean. So this by itself, it just tells me about my process, how it is, where it is centered around which number, the mean. That's it. But it doesn't tell me much about the whether my process is meeting customer requirements or meeting standards or published rates. So the thing that tells me more about that is when we place the upper and lower specification limits. These can be specified by ministry or by whatever process you are dealing with in your educational system. Let's say reply back to an email within 24 hours. So that's like from 0 up to 24 hours. I have to have plus or minus. So get 24 hours plus or minus 2 hours, like a safety tolerance. Okay, so and it can be applied in many other contexts as well. So what I want you to realize is that when we place those limits, we call them specification limits, then we can talk about the Z score. So it's showing this picture here, it's having a score of 4. So which means this process is running at sigma level or level of quality of 4. Why? Because the limits are at 4 standard deviations above and below the mean. So what does that mean? It means if I go down 99.9937% of my process output is a good output, is acceptable, because it's the area under the curve. The total area is 100%. Like if you stop at 6 sigma, it's 99.9999998. But if you continue for like this curve flattens out until infinity, like it doesn't touch 0. So, but we only go up to 6 sigma. So if you want the process to be running at Z score 6, so the limits will be there. at 6, plus 6, minus 6. So again, this is just a representation for the level of quality met. And it can be applied in many contexts. Okay. So understanding, what a process can do, a process generates what we call defects. Defects are like errors, unacceptable output from the process. And the defects are shown here under the curve, higher than USL. So this is an unacceptable output, or here. So if, let's say, I am a professor and I get an email from my student or some kind of a message, the student is inquiring about some topic, or what do we have to study for tomorrow, or whatever, then let's say our agreed upon answer or get back to the student by 24 hours plus 2 hours minus 2 hours, let's say, and I reply back after 48 hours, 2 days. So I have a defect. I generated a defect. So if too many of these defects now are showing up in the system, then there is a problem that I have to solve. And I will generate the data, collect the data, look for the root cause of this defect. Maybe we are understaffed, or maybe I'm too busy, and this happens a lot. And the reason, you see, in most schools today, I used to teach a course at a college here in Ottawa, Algonquin College, and the students tend to be really stressed and anxious. It's just because most of them really coming out from high school, and they want to do well. And so one student was sending me an email, and the email was going in my spam folder. I never noticed the email, and the student got really upset, and because it took me like 2 days to see it. So they want quick answer, especially momentarily. If you can reply back on the spot, that'll be the best. Otherwise, this will create added on stress. It's not like in the free world of business now. We get so many emails and we don't even see them. In the school, it's different. The student can be upset and relieve their stress on the school. So anyway, there are opportunities for defects. And what is a defective unit? It's like a unit, or we call it a unit. Like in the case of reply to an email, this is the unit. If you like, maybe you can say appraising, the student performance, like marking the test, can also be having defect in it. So we need to understand the nature of the defect. So if there is like a unit with more than one defect, it is deemed to be defective. Anyway, these are just certain definitions within Lean. Okay, so what is Z-score good for? Just to tell you, I mean, the difference between level 3 and level 6, it's a huge difference. There was a research done on the publishing companies. So they say when we are publishing a book at Z-score 3, the outcome is like 1.5 misspelled word on each page. So if you go to 6, it's like 1 misspelled word in all of the books contained in a library. So most companies who took Lean Six Sigma seriously, and they adopted it as a methodology for operational excellence and continuous improvement, We call them world-class industrial Z-score, 6. Average industrial is 4. You don't need to go to 6 if the cost that is involved for a company to operate at Sigma level 6 is not justified, and maybe you say, okay, it's not really justified cost for me, I can be happy with 4. That's fine. But this is the world-class companies like Nestle. I mean, I just give you some examples. I used to do automation systems in factories and worked with Nestle applications. So that's an example of a world-class company, Pepsi, Coca-Cola, whatever. They operate at this level of Sigma or Z-score. All right, so this is an introduction to Lean Six Sigma, quick introduction. Now, talking about the education sector, we have so many different kinds of variation that can exist. Like, for example, student enrollment process. And every type of variation, I can mention the issue and how Six Sigma can tackle that. You can have, like student enrollment, again, starting with application process or procedure across different departments. Okay, so we need to have a standardized way of submitting applications, and we need to set like a promise to the student that they'll get an answer by a certain date. So these dates are to be respected because the student can be applying at different universities and they want to know quickly, whether they're accepted or not. So if we are not consistent, that's a problem. That will generate poor quality and complaints. And, basically, that's what makes certain schools superior. It's just because they really offer a service where they are observing all of these things seriously. Grading and assessment, like we can't be grading a test. Let's say we have variation now between professors, and the same professor may be having variation as well, which is one time they mark the test different than the next time and different. So we need to standardize, implement standardized grading rubrics. So that's another example. Standardized testing, variations in the quality and difficulty of standardized tests. So all of these are just 3 examples, but you can go on and streamline other areas of variation in your process. And you want to minimize that by collecting data. And I will show you an example in a few minutes. How would we do that? Sometimes people don't see, they tell you, oh, Lean Six Sigma is only applied in manufacturing. No, this is just a myth. It can be applied in any industry, any business. Or sometimes you hear, oh, Lean Six Sigma is not applied anymore. That's a big one, because Lean Six Sigma, it's a continuous improvement methodology. And if we don't want to apply it, it means that we don't want to improve anymore. What's the reason? It's a very risky proposition, right? Okay. What I did also to make it brief and useful, just to ease down the fact that how can you take Lean Six Sigma and fit it to the education services? Well, the best way to do that, not only for education, but for any other industry, is to start with the Lean principles. So Lean is based on principles from beginning of its findings, we have to abide by or observe these principles. So what I did, I took the principles, there are 12 of them, and I mapped them to the education sector. We said earlier, Lean, one of the main goals of Lean is to deliver value. What is value? Well, value is ultimately defined or seen by the customer, because the customer now is making use of our service. So how do we go about defining value? Is, working with the customer, with the student, to understand what they consider valuable. So a student attending a school, you talk, let's say you do it through an interview or a survey or design process. If you are doing a brand new, if you're creating a brand new school, then you have to really know what the student considers valuable for them to join the school, to apply to it, what are their needs and expectations, ensuring that educational programs will align with their goals. And so the students want a school where they can learn and enjoy the learning, have some kind of learning management systems, technology, not really being challenged in such a way that scares them or run away or say, wow, sometimes we need to understand that the students come to school to learn. So we need to provide the learning as well as have some level of difficulty that is acceptable to majority, not make things impossible. And does the school really help them find jobs, like co-op, for example, teach them skills that are up to date with modern days technology, and make them ready for the job market? That's what the big challenge is. And then the second principle is where we look at the value stream mapping of our processes. So we need to realize that the student starts with an application and go through a series of processes and steps to graduation. And we have to have a process map that really show me the educational journey from enrollment to graduation, and find and improving each step of the process, enhance efficiency. So in each step, again, we need to understand, is this step adding value, or is it wasting time, wasting effort, resources, whatever kind of waste is existing. So the third is maintaining flow, ensuring a smooth and continuous flow of work. Basically, if a student applies, join the school, and they don't graduate, they get stuck there. So I look at, this is not flowing. I mean, the flow meaning like students join, and by the graduation date, they graduate. So administrative processes, are some applications piling up, bottlenecks, creating delays in learning experience. So that's all against flow of work. Now the pull system is the principle number 4. Every thing we do is based on demand. So we have demand from industry, employers on the market. So the students establish the demand on our system. So we just don't teach stuff that nobody's going to use, or it becomes a waste of time and money. So align our resources with the student demand. like today we say big demand for cybersecurity, because this is the #1 threat that we are facing. So now schools are really geared up to cybersecurity and artificial intelligence, both of them. So takt time is really like the pulse of the process. We need to maintain the pace. Desired pace of learning, addressing the needs of both fast and slow learners. So again, you can have here issues with slow learners, like people who need accommodation because of certain issues they are experiencing, and so that has to be factored into. Although, like when we look at the students, we have to look at them as individual, personalized plans, and really good schools, they have a file for every student where they personalize so many things to the student, customization per student, And then continuous improvement, that's the culture and the way of thinking that we need to have in place. We need to foster a culture for continuous improvement, really. One piece flow, again, that's like one student at a time, foster personalized learning experiences, allowing students to progress at their own pace. So these are just suggestions. Standardization, applying standardization in application and testing. Wherever we can have grading criteria, administrative procedures, ensure consistency and reduce. This will be very helpful also. Where there is no standardization, there cannot be Kaizen. That's like a quote for one of the pioneers, Taiichi Ono. He's one of the leading pioneers at Toyota who helped in those principles as well at the beginning of, because Toyota used lean, but they really improved it and made it mature. We call it Toyota Production System. So 5S is also, it's about getting organized, your workplace. Probably some of you heard of this before. Promote workplace organization and cleanliness. Jidoka, automation or automation with a human touch, meaning like implement early intervention systems to identify and address learning difficulties. So if somebody is having learning difficulty, a student having learning difficulty, then quickly this has to be identified and implement an intervention system, find out the root cause, and not let it drag. And because again, you are dealing with a person who needs a special attention, And of course, respect for people is one of the main pillars of center pillar of lean, which is respect for students and everybody in the environment, really, administrators and educators, okay, especially students, because they are the customers, right? Using visual management, is also one of the principles that we need to abide by. Okay, so I'm gonna now switch topics. We talked about the 12 principles of lean and how they map to the education sector, things to think about when it comes to lean. And here we want to, there is an approach within Lean Six Sigma called DMAIC, define, measure, analyze, improve, and control. Yeah, so this approach, it's actually one of the approaches is used whenever you have an existing process running in place and you just want to improve it, year after year, or continuously improve the process by solving problems. So process is represented by y equals a function of x. X can be called an input, can be called a root cause or a factor, contributing factor to the problem, or root cause of the problem. The problem always happens in the y. So it can be also called output or effect or response. I like response variable. That's the X factor and the response variable. So this is called y equals f of x thinking. It's a way of thinking. So we cannot control y directly, but we can control x, and therefore y will change, will be better. So remember that. So what we do, we take a practical problem and then we transform it into a statistical problem, then find a statistical solution, and then come back out like we dive into statistics and then we come back out to a practical solution. And I show you an example how this can be applied. So this is the DMAIC methodology used for existing processes, not brand new. If it was like brand new process, we use DFSS, Design for Six Sigma. That's what it stands for, but they're both Lean Six Sigma, very similar to each other, except here we're defining what the problem is and then like initiating, every problem is defined separately. And we are writing down a problem statement, creating a project charter. So anyway, this is like a summary of the whole DMAIC on one page. We start with the voice of the customer, translate the voice of the customer to CTQ, critical to quality measures, and then analyze our stakeholders, create a SIPOC map, that's a process map. But then a lot of work has to be done here, almost like 50% to 70%, depending upon the industry. So in the service, 70%. And then once we know what the problem is, we need to measure how much is the problem having impact. Measure process, operational definition of why, measure system analysis. All of these things are done in the measure phase. And now I know what the gap is. So if I have, let's say, several emails where I reply back to the student late, outside the acceptable tolerance, then I have a gap. I have to fix. This is the problem. I have to fix it. I cannot really stay like this. Otherwise, now things will be piling up and complaints and all of that. And then I analyze my gap through the data to find out what are the X factors contributing to the problem. So I can do both like statistical analysis, inferential statistics. I start off with like preliminary basic tools for root cause analysis, like fishbone diagram. It will help me determine my potential root causes, and then I validate them statistically by using the data. And then now I'm in a position to improve my process, which meaning like I get rid of the root causes. Therefore, my output will change, will be fixed basically. And then I put a control mechanism, control plan, we call it control plan, to sustain the improvement so it doesn't go back to where it was. So I quickly now, I would say, define, measure in every phase of this cycle. I can, in the define phase, I clearly define the problem or opportunity for improvement, and then I do the activities for resolving the problem. Okay. In the measure phase, now let me, that's the analyze phase. Again, this is saying the previous slide was generic. It's not industry specific, but this is more industry education specific. Okay, what are the things you do in the education sector? Analyze and improve. So as you see here in the define phase, we know what the problem is, and then we define what the goals and objectives for improvement. Okay, so if we are being late to reply to students, then I have to put my goal is to meet my target, a specified target, which is reply within 24 hours plus or minus 2 hours, acceptable tolerance. Here is the measure phase to help me identify KPIs to track and measure progress. Analyze. This is where I get my data to be helping me, because DMAIC is a data-driven decision-making tool or data-driven problem-solving tool, because you want to make use of the data. And today it's very easy to have data because we have systems, we have everything is logged into the system that we use. Okay, learning management system, if you like. And then this is the control phase where we establish controls to monitor and sustain the improvement. Let me show you an example. This is a basic example. A school likes to maintain the passing rate. Let's say 100 students take an exam. This is more like a technician, a trade, taking an exam to become certified technician. So this rate is declining. So there is a problem, because when the rate starts to decline, passing rate, then that's not good for the school, and not only to the students, but for the school too. So we define what the problem is using y equal f of x thinking. So y is really the scores. They depend on x, and x is the x factors, can be place of training, that's x1, x2, how often skills are used, experience level, elapsed time since last training. So now I identified like these three x's, and then looking, that's your statistical problem. So that's, we said, practical problem becomes a statistical problem, then statistical solutions. These sections of the exam are highest trouble spots. Experience is the most significant factor in passing. So what this turns out to be, that why the rate is declining, because the experience X factor called experience is really causing the marks to go down, because we are testing people who don't have experience, but we are expecting them to have experience. So we have to be careful. So focus training on 3 areas of inexperience for inexperienced technicians. So when somebody doesn't have experience, it's not their fault. It's just because maybe they just graduated. And now we cannot test them the same way as somebody who has like 5 years of experience. So to be fair, and then I will have to change my exam based on the fact whether or not the candidate have experience or not. So that's just a simple example about how do you analyze the data for that. Anyway, I would have loved to have more opportunity to explore further and expand, but I think this is a quick introduction on how you can say, well, Lean Six Sigma with training, services, education. Any questions you have, I'll be happy to hear it from you. Or hello. Any questions?
Great, thanks for that. I don't see any questions yet, so let's give everybody just a minute to ask any questions in the chat there.
I don't see the chat. There is.
That's okay, I'll monitor the chat there, so.
Okay. Yeah.
So,
Okay. Can you see my screen?
yeah.
Okay. Yeah, I see the chat now. Okay. Best software for DMake. I have a question from with no educational experience. Okay. Now let me go up to the top. Okay. Yeah, some people they want the slides. We will email them. I will email them to you, Jennifer. Yeah, I have a question here. Have you worked with Dropout? Yeah, that's true. Well, a dropout is really to be investigated and find out the root cause and the reasons behind it for sure.
There's another question. How do you explain standard deviation to someone that works on the production floor with no educational experience?
Yeah, good question. I would take an example, something that easy to relate to, and then show them that standard deviation is just a measure of spread of the data, of the bell curve. Now, any process, when you plot it, you plot the output of the process. That's when it's something like a bell curve. And practically speaking, you know, it's standard deviation. It tells me how pointy the peak of the curve is or how flat it is, like spread apart. And practically, what does it mean? It means, let's say, take an example, average mark 99, the mark that somebody gets 90% on math test. But the standard deviation is like 0.5. So you will end up having pointy curve, meaning that majority of people are around 90. Majority of students got around 90, above, little bit above, little bit below. But if the spread was like 10 or 15, then you will say, okay, I'll have more spread. The marks are more spread apart. Now, same thing applies to anything else you in the data. So you don't want to have them read formulas. Just make it more practical. Yeah. Any other questions?
There's several questions about software packages that you like for process mapping or statistical analysis.
Yeah, there are many software that you can get your hand on. And the question is whether you are willing to pay and your organization is willing to take the cost. Like Minitab is well known. It's called Minitab. I will type it here in the Minitab. The reason I like this one, it's one-stop shop. It does process mapping. It has many modules and it does statistical testing, all the statistics tests. But that tends to be a bit expensive, I would say. So there is another one, Sigma XL, which is a lot cheaper, like maybe $150 for a license. But this is mainly statistical tests that you can run through it. It's quite powerful as well, like Minitab. For process mapping, there are many packages that you can process. There is one called Flow, and many of them I just can't recall the name. I came across recently. But if you like something useful, if you're trying to implement Lean Six Sigma, look at a company. I shouldn't be advertising, but that's okay. More Stream. I don't get anything from them. More Steam. Sorry, More Steam. They have actually a software again that does everything, like draw maps, process maps, as well as statistical tests, as well as project management. Because to solve a problem, you saw at the beginning, we declare a charter. We create a project charter, which is project management. So you need to really have a problem well-defined, have a goal well-defined, then put some action plan, some time limits, say by when you want the problem gone. So you need some kind of project management tools as well. There are many, many of them. Yeah. Any other questions, please?
I think we're just about out of time. So I want to thank you again for the talk today. That was really good. Like to hear about all the education examples that you have used in Six Sigma. So thanks for your time, and I think we'll be ending the webinar here.
Thank you. Thank you likewise, Jennifer, and everyone else attending the presentation. I will email you the PDFs in a few minutes.
Thank you.
Okay, thank you.
Bye-bye.
Bye-bye. Have a